Okay, so the question given is how to compare surface area and volume of similar right rectangular prisms. So first make sure we understand what it means by similar right rectangular prisms. What this means is that each dimension of one right rectangular prism is going to be multiplied by a similar factor, which is going to equal the dimensions of another right rectangular prism. And this is what it's going to look like. So a prism that is 1 by 2 by 3 is equal to a prism 2 by 4 by 6 multiplied by this factor of k. And this factor of k, in this case, is going to equal 1/2, because 1/2 times 2, 1, 1/2 times 4, 1/2 times 2, 1, 1/2 times 4, 2, 1/2 times 6, 3. And this is going to equal what's on the left side. And because each of these dimensions multiplied by the same factor equals this dimensions, then we can declare that in this case, these are similar right rectangular prisms. So using this principle for our equation, let's first define the surface area x as 2 times LW plus WD plus DL. And using what we just talked about, we're going to multiply each of these dimensions by the same factor of k. And we're going to set that equal to our surface area y. And that's going to look like this. So Sy equals 2 times KL times KW, and so on and so on. And if we work this out, it's going to look like this. We're going to factor out this k squared that we're going to be ended up with. And then it's just simply going to look like this. Sy equals k squared Sx. So in this case, where it's just comparing, it's just this k by itself, this is k squared, and that's how we're going to relate these surface areas. And because we're solving for this k value, so k squared x times Sx divided by Sx equals Sy divided by Sx, which is going to equal this k squared value. And if we work that out, 1450 divided by 58, that's going to equal 25. So k squared equals 25, and then 25 root is going to equal 5. Just going to give us this easy number right here. K equals 5. So the same way that we can't just use the regular k value to compare the surface areas for this, we can't use the regular k value to compare the volumes of these two prisms. So similar logic applies. It's not going to be the k squared. It's for volume, it's actually going to be k cubed. So Vy times k cubed equals Vx in this case. And then we can rearrange that to look like this. Vy divided by k cubed equals Vx. And then this gives us a good relationship that we can use to solve what it's asking for, which is the sum of the volumes of the two prisms. So if we write that out really quickly, the V total equals Vx plus Vy. But we're not given a Vx. What we are given is this relationship right here. So if we just replace this Vx with this relationship we found, we can find that the V total is going to equal 1 divided by k cubed times Vy plus Vy is going to give us our V total. So our Vy, which is 1250, this divided by k cubed, which is 125, that's going to give us 10. 10 plus original 1250, that's going to give us 1260, which is our V totals. So our V total, our total volume of both rectangular prisms, is going to equal 1,260 centimeters cubed. All right, great.